This is chapter 9 of the Big Ideas book covering right triangles and trig. This is the skills needed for the chapter. These are the three objectives. 1. To simplify a radical. 2. To rationalize the denominator. And 3. To solve proportions. Okay? These are all the skills that you need before the chapter starts. Right? So, we are going to first use properties of radicals. Here, they're asking us to simplify the square root of 128. We can use the product, right? We can split the radical and simplify it, okay? The square root of 128 can be broken up, okay? 128 can have two factors, 64 and 2. So I split it up based on its factors, right? Because 64 times 2 is 128. The reason why I split it up using the number 64 is because 64 is a perfect square. Okay? The square root of 64 is actually 8. Right? Do you see how I simplify this by breaking down the square root of 64 into just 8? Right? So, and I can just recombine it. This becomes 8 square root of 2. This is the process of simplifying a radical, okay? Is you're going to factor it right here into its perfect squares. All right. So, some perfect squares that you need to know, right? These are all your perfect square roots. The square root of 1 is always 1. Right? Square root of 4 is 2. Square root of 9 is 3. This goes up all the way to 15. These are all the necessary things that you need to remember. Right? 128 can be broken up into, even the number 4 times 32. Okay? You can use something else. But again, I'm always looking for the highest perfect square root. Okay? So this is some chart that you will need to have and you should also memorize. Okay? Where these perfect square roots come from, they come from your perfect square chart. Okay, these are all your perfect squares, right? The side of 2 and 2 makes the area of 4. The side of 3 and 3 makes 9. 4 and 4 makes 16. These are all the perfect areas of a square. 1, 4, 9, 16, 35, 36, 49, 64, 81, and 100, and so forth, right? 121 is also a perfect square. 144 is a perfect square, right? Good. So you would also, these is where all your perfect square root comes from, okay? And you would need to memorize it to simplify these radicals. Alright, the next skill that you need to do is to rationalize the denominator. Rationalizing the denominator is, do you see this fraction here? The denominator, which is the downside, look at the letter D, right, has a radical in it. You're not allowed to have a radical on the bottom. There's no math rule to why you are not allowed to have a radical on the bottom, but it's not that great because a long time ago, when people knew slide rules, you couldn't really calculate it, right? So you need to just learn how to get rid of the square root on the bottom, right? So to do that, to rationalize the denominator is when we move like a square root or a cube root from the bottom of a fraction to the top. Okay, let's see how it works in action to get a better understanding of it. So I have 4 divided by the square root of 5. Again, this is problematic because of the square root of 5 on the bottom. I'm going to multiply by the value of 1, which is essentially multiplying by square root of 5 times the square root of 5. The reason why I multiply the top and the bottom by square root of 5 is because, based on the product rule, look at what happens to the bottom. Square root of 5 times square root of 5 becomes square root of 25. Right? And what is the square root of 25? That simplifies into 5. Do you see how, because I multiplied by the square root of 5 to the top and bottom, I got rid of the square root on bottom because it became a perfect square? Right? Look at the perfect squares, right? Okay? And your square root. Do you see how 5 times 5 becomes 25? Alright, so that is why it's necessary to do that. Okay? Right, so right now you have the first problems 1 through 6. 1, 2, and 3 is going to ask you to just simplify that expression, which is all radicals, and 4, for you to simplify those expressions, which are all fractions, you would have to rationalize the denominator. Alright, pause the video right now if you would like to try it, because I'm going to go over the solution. Alright, here's the solution. Number 1, the square root of 75. It's 5 square root of 3. Here, the two factors that I broke 75 up to is 25 and 3, because 25 is perfect. Square root of 25 becomes 5, so it becomes 5 times square root of 3 would be the simplified of the expression square root of 75. Number 2, square root of 270. Right, it can be broken down into 9 times 30. The reason I use 9 is because the square root of 9 can be broken up into 3. Because square root of 9 is equal to 3. Okay, and the final answer is 3 times square root of 30. There isn't any perfect square here that you can. There isn't any perfect square factors here, right? You have 1, 4, 9, 25, then the next one's 36. So square root of 30 can't really be simplified down further. The next one, 135, okay? Square root of 135 are broken up into 9 times 15. Again, because the square root of 9 is 3. Square root of 15 I leave because there's nothing else that can go into it. So this simplifies into 3 times square root of 15. Notice how, again, I am pulling out, or I'm factoring that number into its largest perfect square. And how am I doing that or remembering? I'm using that chart. Okay, that is why that chart is very important. Alright, the second one, 4, 5, and 6. This is all the process of rationalizing the denominator. Alright, so again, here I multiply the top and the bottom by the square root of 7. You're allowed to do this because square root of 7 over square root of 7 is just 1. That's why you're allowed to do that. Okay, the denominator, square root of 7 times square root of 7, is the square root of 49. The top, 2 times square root of 7. The bottom, square root of 49 is simplified into 7. You see, the denominator has no more radical or square root symbol. 5. I multiply the top and the bottom by square root of 2. The denominator, square root of 2 times square root of 2 becomes square root of 4. That is simplified into 2. So the answer is 5 square root. Ooh, this is wrong. This should be 5 square root 2 divided by 2. There was an error. I think I copied this over wrong. Alright, so again, it should be 5 square root 2 divided by 2. Alright, sorry for the error. Next one, 12 divided by square root of 6. Multiply the top and the bottom by square root of 6. Okay. This is bad. Error. Again, square root of 6 times square root of 6 is 36. So this should be a 36 here. Square root of 36 is simplified into 6. The top, 12 times 6. Okay. Again, there's an error. This should be 5 square root of 2 divided by 2. And this answer should be 12 square root 6 divided by 6. The answer is correct here. This should be a 36. Okay. Sorry for those errors. Next, you then want you to solve the proportion. Okay. To solve the proportion, you have to do something called cross multiplication. Okay. X times 2, okay, 2 times x right here, and right here on the right hand side, 10 times 3 is 3 times 10, okay. 2x is on the left hand side, 3 times 10 is 30. Then you divide each side by 2 because you're trying to get x alone, you're trying to isolate x, and you get x equals 15, okay. If you plug in 15 here, you're going to see how it simplifies. 15 divided by 10 is simplified into 3 over 2, okay. But we use this process of cross product to get us there, okay? Alright, so using that method of cross product, right, Please solve the following proportions. Okay, you can pause the video if you need more time. Okay. All right, let's look at the solution. First of all, I cross multiply, so it should be 4x. All right, 4 times x, and the next one 3 times 12. Good. Left hand side is 4x. Right hand side 3 times 12 is 36. I'm trying to get x alone, so divide 4 to both sides. 36 divided by 4 is 9. So the x here value is 9, because 9 divided by 12 should be equal to 3 over 4. Next, x over 3 is equal to 5 over 2. Cross multiply, so 2 times x. Right hand side 5 times 3. 2 times x is 2x. Right hand side 5 times 3 is 15. Divide 2 to both sides. Alright, you get x on the left. On the right hand side, you get a 15 divided by 2. What's another way of thinking about? Alright, you can't really simplify this. In decimal form, it's 7.5. Next, cross multiply. 4 times 56 is on the left hand side. On the right hand side, 7 times x. 4 times 56 is 24. 7 times x is just 7x. Divide, again, this is wrong. Divide this and this by 7. 224 divided by 7 is 32. Okay? Alright, that should be correct. Let me just double check that. That is correct. Alright, again, this is an error. There shouldn't be a 4 here. Okay? Alright, but that's it. Next, last one is the abstract reasoning. The product property of a radical allows you to simplify the square root of a product. Are you able to simplify the square root of a sum of a difference? Explain. So, this is the product property again. The square root of a, b, can be broken up into the square root of a times square root of b. The example, we've did it before, but this example I'm going to use here is the square root of 75. The square root of 75 can be broken up into square root of 25 and times square root of 3. The beauty is because square root of 25 is the perfect square of the number 5. Okay? So, they're asking for the sum. Does the sum work the same way? Does the square root of 75 equal the square root of 50 plus 25? Right? That's what the question's asking for. The answer is actually no, because there's multiple ways of explaining it, but I'm going to explain this using the algebra method. The square root symbol here is basically to the power of 1/2, right? So a squared is a to the power of 1/2, and b the square root of b is b to the power of 1/2. You can't really add these because they have to be the same base. The base here is a and the base here is b. You can't really do that, okay? And if you also want to think about what the square root is right? It comes from the perfect square of the sides of a square, okay? And remember, they have to be. You can't really add that to get the area of the square. You have to multiply it, right? Right? So